Hello viewers, in today's class we are going to discuss one important topic from three-dimensional geometry, right? And here we have to discuss the problem in which we have to find the coordinates of the foot of the perpendicular on a given plane, and then we have to find the length of that perpendicular and also the equation of the perpendicular, right? So here what we will do, will first draw a rough diagram of this problem, and then we will see what we have to find, right? So now here what we are given the equation of a plane, right? Suppose this is the given plane whose equation is given as 2x minus 3y plus 4z plus 9 is equal to 0, right? So let us denote the plane by P, and we can write its equation as 2x minus 3y plus 4z plus 9 is equal to 0, right? And here we are given a point, say A, which is this point 1 comma minus 2 comma 3, right? So let us take this point over here, and this is 1 minus 2 and 3, right? Okay, so this is the situation, this is the plane P, and this is the given point A, right? So what we are going to do in this video, see, if we draw a perpendicular from this point A to this plane P, right? So let us draw the perpendicular like this, right? So this perpendicular, say this point is M, right? So M is the foot of the perpendicular, right? So M is the foot of the perpendicular which has been drawn from this point A to this plane P, right? Okay, and here we have to find the equation of this perpendicular, right? So we have to first find the coordinates of this point M, right? So then we'll find the equation of this perpendicular line, that is AM, and then we'll find the length of this perpendicular AM, right? So we have to do three tasks here, and first the coordinates of this point M, then the equation of this perpendicular AM, and then we'll find the distance AM, right? Okay, so now here we'll make use of the concept of straight line and some concepts of plane to solve this problem. So let us first use the concept of direction ratios, right? So see, here this is the plane P, right? And the normal to this plane is like this, right? This is the normal vector to this plane P, right? So obviously this normal vector is parallel to this perpendicular AM, right? This is a very important concept while dealing with lines and planes, right? So the normal vector is parallel to this perpendicular AM, right? And see, the direction ratios of the normal vector, right? The normal vector, the directions of the direction ratios of the normal vector can be obtained from the equation of the plane itself, right? See, here the coefficients of x, y and z are 2, minus 3 and 4 respectively, right? So the direction ratios of the normal vector to the plane P are given by the coefficients of x, y and z in the equation of the or the Cartesian equation of the plane, right? So here we have obtained the direction ratios of the normal vector as 2, minus 3 and 4, right? Okay, so the next concept is, since this normal vector is parallel to this perpendicular AM, right? And AM is a line, right? Okay, so from the concept of straight lines, we know that if two vectors are parallel, then their direction ratios are either equal or proportional, right? So here these two vectors, the vector n and am, are parallel, right? So the direction ratios of this line am are also 2 comma minus 3 comma 4, right? So here these two are parallel, so the normal vector and am has the same or proportional direction ratios, right? Okay, so now the third concept is we have to write the equation of am, right? So we will write equation of am. So here we'll use the Cartesian equation of a straight line passing through a point, right? See, if we have a straight line which passes through some point, say x1, y1, z1, and having direction ratios a, b, and c, then the equation of such a line is given by x minus x1 over a, y minus y1 over b, and z minus z1 over c, right? And here we have to find the equation of am, right? And this am passes through 1 comma minus 2 comma 3, right? So x1 y1 z1 can be taken as 1 minus 2 and 3, right? And the direction ratios of am can be taken as 2 minus 3 and 4, right? Okay, so now we can write the equation of am as x minus 1 over 2. Then we can write y, here we have the negative 2, so we have plus 2 here, and we have minus 3, and then we have z minus z1, z1 is 3, so we have z minus 3 over 4, right? So viewers, the equation of this perpendicular is given by this equation, right? So we have find out the equation of this perpendicular. Am as x minus 1 over 2 is equal to y plus 2 over minus 3, z minus 3 over 4, right? Okay, so now our next step is to find out the coordinates of this point M, right? So now the fourth concept which will be used here to find the coordinates of M is the concept of a general point lying on a line, right? On a line. So here AM is the given perpendicular or the given line, and M lies on this line AM, right? So what we will do here in the equation of AM, we'll take a scalar lambda, right? So now we'll take some scalar lambda, and this is lambda is a scalar, and from this equation we'll find the value of x, y, and z, right? So we can write x minus 1 over 2 is equal to lambda. Then we can write y plus 2 over minus 3 is equal to lambda. Then z minus 3 over 4 is equal to lambda, right? So from here we'll get x is equal to 2 lambda plus 1. From here we'll get y is equal to minus 3 lambda minus 2, and from here we'll get z is equal to 4 lambda plus 3, right? So now we have obtained the coordinates of this point M as x, y, z for some value of lambda, right? In fact, x, y, z represents the coordinates of the general point lying on this line AM, right? And M is one of the point which lies on this line AM, right? For some value of lambda, and we have to find that value of lambda for which M lies on this line AM, right? So M has 2 lambda plus 1. Here we have minus 3 lambda minus 2, and here we have 4 lambda plus 3, right? And now the fifth concept which will be used here is that this point M, it lies on the plane P, right? Since see here M lies on this line AM as well as on the plane P, right? So M must satisfy the equation of the plane P, right? So what we will do, we'll substitute this coordinate in the equation of the plane, right? So we'll take x, y and z and we'll substitute these values of x, y and z in equation 1. So now we can write here 2 times x is 2 lambda plus 1, then we have minus 3, then y is minus 3 lambda minus 2, then we have 4 times z is 4 lambda plus 3, and this is plus 9 is equal to 0, right? Now let us simplify it. So we have 4 lambda plus 2, here we have plus 9 lambda plus 6, and here we have 16 lambda plus 12 plus 9 is equal to 0, right? Now this is a linear equation in lambda, so we can solve it for lambda. So this is 25 plus 4, 29 lambda. Here we have 6 plus 2, 8, 8 plus 12, 20 plus 9, 29, right? So now we can write 29 lambda is equal to minus 29. So lambda is equal to minus 29 over 29, that is minus 1, right? So lambda is equal to minus 1, right? So for this value of lambda, this point represent this point M, right? So now the coordinates of the point M, which represents the foot of the perpendicular, are given by here we will take lambda is equal to minus 1, so we have minus 2 plus 1. Here we'll take lambda equal to minus 1, then we have minus 3 here, minus 1, minus 2, then we have 4 times minus 1 plus 3, right? So now we have minus 1 here, this is plus 3 minus 2, that is 1, and here we have minus 4 plus 3, and that is minus 1, right? So viewers, the coordinates of the foot of the perpendicular M are given by minus 1, 1 and minus 1, right? Okay, so now we have to find the length of this perpendicular, right? So what we will do, here we are given 2 points, A is 1, minus 2, 3, and we have M is minus 1, 1 and minus 1, right? And now we have to find the length AM. So here we'll use the distance formula in 3-dimensional geometry. So the distance formula goes like this. The distance D or AM is given by square root of x2 minus x1 whole square. Here we have y2 minus y1 whole square, and here we have z2 minus z1 whole square, right? So this is x1 y1 z1, this point is x2 y2 z2, right? So we can now have x2 minus x1, so we have minus 1 square, then we have 1 plus 2 square, and here we have minus 1 minus 3 square, right? So this is minus 2 square, that is 4, this is 2 plus 1, 3 square is 9, and here we have minus 4 square is 16, right? So we have here square root of 29 units, right? So the length of this perpendicular AM is given by square root of 29, right? So viewers, this is how we can solve this problem.